Hello everyone, I'm Mashrur Sakib Choyon, welcoming you all to this presentation on the paper titled An Interactive Low-Cost Smart Assistant System Information Kiosk as Plug-and-Play Device. It is based on a project work carried out to develop this exclusive system. My fellow authors are ASM Mehedi Hassan, Abu Hasnat Muhammad Rhydwan, and Chowdhury Akram Hossain, who is the Senior Assistant Professor. And we are from the Department of Electrical and Electronics Engineering, American International University, Bangladesh. So these are the points that we are going to discuss today in this presentation. The real motivation of this particular project was to build an effective kiosk system which would be dynamic, user-friendly, user-interactive, low-cost, secured, and the device would be a plug-and-play device. In addition to that, our goal also includes satisfying user experiences and serve the purpose of any organization. Now let's take a look at the working principle of the system. In this diagram, we can see how the whole system is carried out in such a user-interactive method. The Raspberry Pi works as the main processor of the system. The Raspberry Pi is connected to the touchscreen display, which the user uses to see the data as well as programs of the system and can provide different data input to the system. There is also a Pi camera connected to the Raspberry Pi that constantly scans the area in front of it to detect any human with the help of image processing. Whenever any human is detected, the display screen will light up with a welcoming sound, but the device usually stays in a sleep mode while being inactive. There are several sensors used in this system that are connected to the Arduino Uno microcontroller, which is ultimately connected to the Raspberry Pi. The Raspberry Pi is connected to the database server as well. As the Raspberry Pi is connected to the main power supply, it generates power to all other parts of the device and controls them. Now let's take a look at how the image processing is carried out by the device. In the beginning, the camera constantly scans the area in front of it to detect any human. If no human is detected in front of the camera keeps on scanning. If any human is detected at a certain distance in front of it, the system identifies the gender, emotion, and age of the human user. Then the display screen, which initially stays in sleep mode, lights up with a welcoming sound, and the main menu of the home page will appear. With the help of computer vision and machine learning, the system would suggest events and news according to the user's gender and emotion. Then if the user provides any command to the system, the result will be displayed on the display screen of the device, and if not, the device remains idle or inactive for 5 minutes and then the device will go back to sleep mode. This mitigates the wastage of power consumption by the device. The database of the system was developed in a very efficient manner, where the primary development and management tool used for the database was MySQL. In addition, the tool which was used for loading data to the database was Node.js. In this figure, we can see the relations between different data tables within the database. Here we can see a sample of database management. The tool which was used for program app development is the Electron.js. The tool to access the database with the admin access is the phpMyAdmin. The database was built secured and only the authorized person with the admin access can access the main database. Now let's take a look at the features of the system. One of the most exclusive features developed for the system was the 3D map and email sending feature. The 3D map enables the user to navigate the building floor-wise. In each floor, the list of available persons' offices are displayed. If the user selects on any person or office's name from the list or clicks on any of the icon on the map, the person's detailed information will be shown at the lower portion of the map containing the name, designation, email address, contact number, and other information as well. If the user clicks on any email address, the user will be able to send an email from the device automatically. Using the same concept of the 3D map, we have developed a 3D seat plan feature which is essential for universities and other organizations as well. From the login info of the user, the system would identify the seat of the user in a particular room scheduled for an exam or seminar or meeting. The specific seat of the user would be identified with a different color or marked out from the rest of the seats in the room. To schedule the availability of certain official personnel or faculty members in a university or organization, we have developed a simple mobile app for these personnels. We have used Node.js to develop the app, and we used Android Studio to develop the UI of the app. The system was also developed to avail the benefit of using embedded multiple sensors with it. At the initial stage, we have used RFID module, heart pulse sensor, and temperature and humidity sensor with the device. These sensors are all connected to a single Arduino Uno microcontroller, which is ultimately connected to the Raspberry Pi. Additional sensors can also be connected with the device if required. The outcome of the whole device showed excellent results in all sectors. In the image processing sector, the results showed that it had a success rate of 98.5% in detecting humans, a 95% success rate in detecting gender, an 85% success rate in detecting the age of the user, and 80% success rate in detecting the emotion of the user. The system also detects the face of the certain users that can be used for logging in to the system without any RFID card or username and password. In terms of current and power consumption, the system showed promising results as well. As we can see from the chart, the average current consumption stays below the rate of 1 ampere. Therefore, the power consumption rate stays below 5 watt. Here, most of the current or power are consumed by the touchscreen display. Therefore, we have developed a sleep mode to avoid any unnecessary power wastage. We have made a test run of our system and device in the American International University, Bangladesh. The device has shown great performance and the test run was highly efficient. It had gained a huge amount of popularity among the students and other users of the university because of its user-friendly performance and attractive user interface. Now let's take a look at how our developed kiosk system is better in terms of cost effectiveness as well. In this chart, we can see a comparison between the developed kiosk with 3 other available kiosks in the market. These are the indoor kiosk, the outdoor kiosk, and all-in-one kiosk. But in the end, we can see how significantly low the price is for the developed kiosk, which is almost half the price of the lowest priced kiosk found in the market. We can provide a much efficient kiosk at a lower price, but with more feature than any other found in the market. And none of the kiosks in the market are plug-and-play device and this much dynamic. In the end, we can conclude the talk by saying that we have reached the goals of the project, which are set initially to develop this exclusive information kiosk. It had shown great performance in terms of user experiences and efficiency. We have plans to add more biological data collection features and add more sensors to the system in the later version of the device as well. We have plans to improve the image processing feature even further. As this project was developed from the perspective of a university initially, it can be modified to use in any other organizations like the healthcare organization, corporate organizations, libraries, or in any other public places. Therefore, we can say that we have developed a great product that shows great promises for the future. Thank you all for watching. Stay well. Goodbye.